Welcome to this algebra webinar. And we are going to jump into learning some of the kind of foundational concepts of algebra. All right. So if you have any questions, you need to kind of raise your hand and let me know. All right. Because if you raise your virtual hand, you know how to do that. You have there a button with reactions. Okay. And so you can raise your hand. Okay, I don't know. I don't have the raise hand button, but I did the thumbs up button. So anyways, so that way I can see you and you jump on. Or you can type in the chat if you have a question. So if you whatever is easier for you, that will be great. So now let's go for a quick lesson, okay, in algebra. So I need to actually, let's see, switch the displays. Okay, swap the displays here. All right, I have you there, and let me make sure that I have the chat open to see if there's anyone that wants to add anything in the chat. Just type it in the chat there. Okay, so let me put my windows in the right spot. Okay, so far so good. Any questions, comments, smart remarks? Okay, no, everything all right. Good deal. So let's take a look. So we are going to start today by doing a historical overview of algebra. Okay, so this is going to be a brief history of the development of algebra. And it's one of the ancient sciences, algebra. So algebra started with the Babylonians. They were the first ones to actually develop algebra and counting and numeric systems. This image shows the numerical annotation that the Babylonians used. This is in the cuneiform language that they had. And they use these symbols to represent numbers. Okay, so this is one of the first numeric symbols that have been discovered, the most ancient ones. The Chinese independently developed their own way of counting, of mathematical symbols. The Egyptians also started using mathematics to solve, very simple problems, but important problems. And what do you think that was the drive for developing mathematics, for counting things? What do you think that was the main reason that we have found for people to be able to count or to develop mathematics? What do you think that would be the main function of mathematics in the ancient world?
I don't know, maybe trading or like money, using it to figure that out. I don't know.
Yep, that was the main drive. Okay, so money and trade. Okay, and being able to count and record transactions. Okay, you sold me 10 cows and I gave you 3 pigs. All right, all of that needed to be recorded. And it is interesting that we know that because we have found these tablets written by the Babylonians and the Egyptians actually keeping track of these accounting transactions. Okay. And they had to start in figuring out how to calculate interest. All right. So, for example, I lent you 100 rupees, okay, or 100 whatever, okay, for 10 months. Now you owe me 111. All right. So the other 11 are kind of what is considered the interest, is because I'm letting you use my money for a period of time. Now you need to pay me more for that. And this is something that was developed actually anciently. And it is interesting. The Egyptians, they wrote these things, okay, in papyri and in different areas, receipts and all these documents. And recently, it was discovered in a place outside of Cairo, basically a garbage dump. Okay. And this was an ancient garbage dump. And a lot of these papyri have been preserved for thousands of years in this garbage dump. All right, because Egypt is so dry. It's so dry. The papyri are written in this parchment that it preserves for a long time, and so we have been able to actually rediscover a lot of ancient life and ancient Egyptian life specifically by looking at these papyri that were in the dump. So every time that you throw something to the garbage, just remember that archaeologists may find it thousands of years from now. Okay, especially if you live in a dry area. If you live in a wet area, no chance. So you're fine. Okay. The Greeks also developed a lot of algebra, and we have studied in the geometry course how they developed geometric algebra. Okay, so that was a way of representing relationships between numbers with the length of lines or the areas of figures, rectangles and squares and so on. So that is kind of the ancient civilization. Then we have the period of classical algebra. And in classical algebra, there are three main civilizations that contributed to the development of algebra: Indians, Chinese, and the Arabs and Muslims. Okay, so these were the main contributors of the development of algebra during this time. It is interesting to know that Europe during this time was literally in the dark ages. Okay, so there was almost very, very little development of mathematics or science during this time in that part of the world. But in India, in China, and in the Middle East, we have very important and influential developments of mathematics, especially here in the development of algebra. So let's take a look at some of these developments, okay? So one of the greatest mathematicians of this period is Al-Khwarizmi. Okay, I hope that I'm pronouncing that closely right. Okay, but he was a Persian mathematician, astronomer, geographer. He lived in the Abbasid Caliphate. Okay, so that is the area basically of Iran, Iraq. And this was during the golden age of the Islamic science and scholarship. So about from 780 to 850, okay? So that was the period of time where Al-Khawarizmi lived. And he wrote two very, very influential books. One was on the systematic approach to solving equations, okay? And this is the basis of algebra. And also another system that introduced the concept of zero and paved the way also for using positional numbers. Okay, so before, all the numbers, all the numeric systems were not positional. They were like these ones, of the Chinese or the Babylonians that had symbols. The Greeks, even, they used the letters of the Greek alphabet. So they were not positional systems. They were very difficult to use. The Romans used the Roman numerals that are also made of letters, okay? But none of those systems had zero. So the Indians, okay, we are going to talk about zero in a little bit, they developed the concept of zero Al-Khwarizmi was the one that developed the algebraic, the Arabic numerals, and introduced zero as one of the numerals. Okay, so algebra comes from a word that Al-Khwarizmi kind of developed, and is called algebra. Okay, that is in Arabic, and it means restoration or completion. That is what algebra means, is to restore or to complete. And so this is basically the process of moving a quantity from one side of an equation to the other. You may have already done that, okay? Tell me if you haven't, or you haven't done this. But the idea is basically that you have an equation, and if you want to get, basically, let's say that we start with this equation, x minus 3 equals 7. If we want to find what is the value of x, we want to isolate x on one side of the equation. Okay, and the method of algebra, okay, of restoration and completion, basically says do the same thing on one side of the equation as you do it on the other side of the equation, and then you maintain the equation. Okay, and so in this case, in order to get the x all by itself, what we are going to do is we are going to add plus 3 to both sides of the equation. Okay, so you can see that the equal sign remains this way. I have something, I started with something, so something minus 3 equals 7. That something minus 3 plus 3 is going to also equal 7 plus 3. Okay, oops, I click, all right. So I add whatever I do to one side, I do it to the other. And so when I actually calculate that, the minus 3 and the plus 3 cancel each other, and so I end up with the x. 7 plus 3 is 10. Okay, that is what algebra means. Isn't that interesting? That is one of the main methods of algebra, is basically to do something to the equation, the same thing to both sides of the equation. You can add or subtract something to the same side. The other method, Al-Khwarizmi call it al-Mukabala. Okay, that means balancing or reduction. I don't know Arabic. Okay, I'm just trying, so give me a break. Okay, so, but it's basically kind of the same thing that we have in algebra, all right? But it's the process of subtracting equal quantities from both sides of the equation and then simplifying it. All right, so here we have that now in this equation, we have x on both sides of the equation. So what we are going to do is we are going to try to put x on one side. All right, so by the process of balancing or reduction, al-Mukabala, we are going to have this x, we are going to subtract x from both sides of the equation. So we start with 2x plus 5 equals x plus 10. Okay, so now we are going to subtract x from both sides in order to get rid of basically this x over here. And so now we end up on the right side of the equation just with 10. And on the left side of the equation, we end up with 2x minus x plus 5, which would be, 2x minus x is 1x. Okay, so we have 1x here plus 5. And then we use the process of algebra, all right? So the other process to isolate the x here. So I'm going to subtract 5 from both sides, and I end up with the value of x. All right. So far, so good. So this is the basic methods of algebra, really. You either subtract, something or add something on both sides of the equation in order to balance it or reduce it or to, complete it, okay, and doing it that way. Another kind of third technique of doing this is actually by multiplying or dividing both sides of the equation. And this operation doesn't have a name, like, a cool name in Arabic, but it's basically kind of the same thing. It's still doing algebra, but instead of adding and subtracting, or adding or subtracting, you are multiplying or dividing both sides of the equation the same way. All right. So the mantra is whatever you do on one side, you do it on the other in order to maintain the equality, the equal sign. As long as you do the same thing to both sides of the equation, you are okay. All right. And so here, in this case, we are going to have, let's see, we start with, where are you, my mouse? Oh, here it is. Okay. So we start with 2x equals 8. All right. And so in order to isolate the x, I'm going to divide both sides of the equation by 2. So 2 divided by 2, that simplifies and leaves me with the x here. And 8 divided by 2 equals 4, so x equals 4. All right. By the same token, if I start with x divided by 2 equals 4, then I can multiply both sides. All right. And so this 2, simplifies with this other 2, and I end up with the x by itself, and x equals 8. All right. So you can see here, this is the main thing that we do in algebra. We do that all day long. We either add or subtract or multiply or divide both places, both sides of the equation. And that way it helps us to manipulate the numbers and maintain the equations. Okay. All right. So far, so good. Are we doing okay? Yeah. Have I lost anyone? No, we are okie dokie. Okay, good. So let's keep going. So now we get here to the early modern algebra. And now here, this is an interesting thing. This is the 1500s to the 1800s period. And what happened is the following. You have a couple of very important shifts in geopolitics, okay? One is Marco Polo came back from China and brought a lot of the things that the Chinese had discovered and done to Europe. All right. The other thing that happened was that the Mongols invaded Baghdad. All right. That was the time of the Golden Horde. All right. The Turkic tribes of Central Asia invaded the Middle East, and they destroyed that part of the civilization. They destroyed the library of Baghdad. And so now all the mathematicians had to escape to Europe. And the treaties, the books that they had written and everything, they were now being translated from Arabic to Latin or to Greek, languages that now people in Europe could understand. So this was a massive transfer of knowledge from one area of the world to the other. Okay. And at this time is the time of the Renaissance, where now science started being developed in Europe. And you have some of the main contributors in mathematics, especially in algebra, are Descartes and Fermat. Okay, so in the 17th century, so this was in the 1600s, they developed the concepts of using coordinates to plot points in a plane. So that is the foundation of the coordinate geometry. All right. So have you heard of the Cartesian products? Okay, Cartesian axes or graphs. So those were developed by Descartes. All right, and it's a way of representing now the relationships of algebra visually. And we are going to do a whole lot more on that in this course. All right. So from there, we get into what we call modern algebra. And in modern algebra, there was a woman, Emmy Noether, a German mathematician, that really, she developed abstract algebra. And a lot of the notation and things that we use nowadays came from her, and also from other mathematicians. Euler is another very influential mathematician in this time frame. And this is where we have kind of the modern approach to algebra. And algebra has basically now developed into many subfields, many other areas of study of linear algebra, abstract algebra, Boolean algebra. Boolean algebra is basically dealing with logic and is using computer science a lot. Okay, sets algebra with matrices and so on. So lots of different subfields in this area. We are not going to go into that level in this course. Okay, we are going to probably go more into this area of the modern algebra. All right, at this point in this course. Okay, now let me go back, all right, and introduce you to one of the early, very, very influential mathematicians, Brahma Gupta. He was from India, and he lived actually before Al-Khwarizmi. All right, so he was actually before the mathematician that developed algebra. But Brahma Gupta, he wrote a very important book. This is the title of the book. I'm not going to try to read that in Indian. Okay. But it translated is The Opening of the Universe. Wow, what a title, That is an interesting title for a book, kind of, And he presented in this book the rules for dealing with numbers. And he introduced the concept of zero and of negative numbers. This is amazing, guys, okay? Before that, there was not a concept recorded of the number zero or of negative numbers, all right? So people only counted positive numbers, but they didn't know how to deal with negative numbers. So Brahma Gupta basically introduced all the rules of how to deal and use negative numbers and how to correctly do the rules of how to deal with zero operations. Okay, so these are some of the rules that Brahma Gupta came up with for zero. Some of these rules are correct, others are not correct in the sense that we now have different rules for dealing with zero. Okay, so for example, let's see, rule number 1 says the sum of zero and a negative number is negative. That's good. Okay, so if we have -2 plus 0 is -2. All right, the sum of zero and a positive number is positive. The sum of 0 and 0 is 0. Okay, so that is good. The sum of a positive and a negative is their difference. That is an interesting concept. So, and for us, this seems kind of like, well, duh, obvious. All right, we have been doing this all along. But this is something that Brahma Gupta invented, okay? Before, no one knew about how to deal with negative numbers, okay? So if you have a positive and a negative number, the sum of those two is actually the difference of those two numbers. Or if their values, their absolute values are equal, then the sum is 0. So if you have +6 minus 6, then we have 0. Okay. So that is the very important rule also. A positive or negative number when divided by 0 is a fraction with the 0 as the denominator. This is a rule that we do not now use. Okay, we don't use this rule. All right, so Brahma Gupta was basically saying, I don't know what is the result of dividing by 0, but I'm going to say that is a fraction where the denominator is 0. So you have, the number that you started, and then you have the fraction and divided by 0. But we cannot solve it. We cannot go beyond that. All right. We don't accept that now as the answer to that question. What is the division by 0? And we are going to go over that in a second. The next rule here is 0 divided by a negative or positive number is either 0 or is expressed as a fraction with 0 as numerator and the finite quantity as the denominator. We do not also accept this as correct anymore. Marcy, you will have your hand raised here.
This is Elijah here.
Hi, Elijah. Good to see you.
I was wondering, is there any practical applications for negative numbers? Because I can't think of any.
Oh, no. Yes, there's lots of practical applications. Okay. So let me give you a very quick example. Okay. So let's say that I have a thermometer. Okay. And the temperature outside is 12 degrees. Okay. 12 degrees Fahrenheit, let's say. So pretty cold, very cold. 12 degrees Fahrenheit is below freezing. But then the temperature decreases by 20 degrees. Okay, so we have 12 degrees Fahrenheit, but now the temperature decreases by 20 degrees. What is the temperature now, Eliza?
-8.
-8. Okay, there you have one application of negative numbers. Okay, so that is just one way of thinking about an application of negative numbers. Okay, in accounting, let's suppose that I owe you $50. Okay, I owe you $50. And so you write in your accounting book, okay, Pablo owes me $50, And
I wish.
You wish?
Yeah.
Okay, I wish. I don't wish that. But let's suppose that. Okay, and now let's suppose that I pay you $60. All right. What are you going to write in your accounting book?
Now I owe you $10.
Now you owe me $10. Exactly, yes. And that is kind of how anciently the accountants would have dealt with that. They would have basically say, Pablo owes me 50, he paid me 60, I owe him 10. And so you can see there that you keep everything in positive numbers. What you are changing is who is owing who the money. Okay. But if you were going to say, let's always have in my book, my account is my relationship with Pablo. Okay. So in that sense, I'm going to put Pablo owes me 50. So I have 50 in the book. He paid me 60, so I'm going to subtract $60. So now my accounting is going to say minus 10. Okay. That minus 10 reflects that now you owe me the $10. Does that make sense?
Yeah.
All right, good. Okay, so those are just some, a couple of the applications of negative numbers. There's, of course, a lot more very, very important and useful applications of negative numbers. Okay, so, but the negative numbers allowed us to actually solve what happens when we have a subtraction of one number minus a larger number. Okay, then the result is going to be a negative number. Okay, so that is what we have. Okay, and we are going to talk about this in a little bit. In a second, we'll get to that. Okay, so these last three rules of Brahma Gupta we do not use nowadays. The 0 divided by 0 is 0. We also don't use it. Okay, and this is what happens with 0. So 0 was developed in India. From India it went to the Middle East. Okay, like we were talking about, al-Khwarizmi. Okay, use 0 as the foundational work in algebra. So very, very important concept. And then it went to Europe about the 12th century AD. So then some Latin translators like Fibonacci, okay, translated the works of the Arab mathematicians and introduced now the Arabic numbers and the concept of 0 and the concept of negative numbers. So all these concepts actually came to Europe pretty late, really, if you think about it. So the concept of negative numbers were first developed in China. From China, then they were in India, from India to the Middle East, and then they reached Europe in the 17th century. Okay, so really, we have this concept kind of very late for reaching us. Yes, Elisha? You have your hand up again. Yeah.
Oh, sorry, I forgot to put it down.
Oh, okay, no problem. All right, excellent. Okay, so let's talk a little bit more about the division by 0. Okay, this is an important concept. So in modern mathematics, division by 0 is undefined. All right, so we basically said any number divided by 0 is, we don't know. Okay, so we basically said is not defined. We cannot even do division by 0. So whenever you encounter something that introduces a division by 0, throw up your arms up in the air, run around the room screaming and everything and saying, undefined, undefined, okay? And you cannot go further than that. 0 divided by 0 is also considered indeterminate. Okay, so basically you cannot get to a solution for that. And let's take a look at why is this the case. All right, so we are going to talk about the division by 0 and looking at that really quickly. The mathematician that developed this concept is a French mathematician, Augustin Louis Cauchy. All right, and he basically helped to define why the division by 0 is undefined. All right, and the idea is the following here. Oops, let me go to the presentation again. So let's switch. Oops. Let's switch the display. Oh, there we go. Okay. So the idea is the following. So here we have a Cartesian graph. All right, so here is 0, the origin. This is the x-axis, and this is y. All right, and so let's consider this function here, this equation here, 1 divided by x. Okay, so let's see, if x equals 1, so we have 1 divided by 1 is going to be 1. Okay, so that would be this point here. Okay, so this point here, 1 divided by 1 is the 1. All right. What happens if we do 1 divided by 2? What would be the result of 1 divided by 2? So now x is not 1 here, is 2. So what would be the solution of that? So if x is 2,
Turn the lights off, Melody. Is that off? Yeah.
okay, so 1/2. I hope I heard that. Okay, so yeah, that would be 1/2. All right, so that would be this point here. What would be if x equals 3? So if we move here to this point, 1/3, then the solution is going to be 1/3. Okay, and can you see that as x keeps growing and growing, this fraction is going to get closer and closer to 0, but it's not going to ever reach 0. Okay? Elijah, let's see, let's mute there. Okay, there we go. Okay, so as we get this fraction smaller and smaller, closer to 0, the value of the function is going to go higher to infinity. Okay, to a positive infinity, so it's going to go, so as x grows, again, so as x grows to infinity, the fraction is going to get closer and closer to 0, okay? But if I do the same thing with negative numbers, if I'm going to do the same thing here with negative numbers, the solution is going to be the same, but it's going to go towards minus infinity, okay? And so that is the problem, why it is undefined, all right? So the closer I get to 0, the higher the equation is going to go, but I'm never going to know whether it's minus infinity, okay, minus infinity or positive infinity. All right. And so that is why division by 0 is undefined. Okay. Let's see. Have I explained that correctly? Okay. Let's see if we keep thinking about it. Emma, you have a kind of a little confused face. Let's see. If I'm not getting you, I think I'm missing something.
I'm not sure. It's just like I've never thought about the fact that you can't divide by 0, and it's kind of blowing my mind a little bit that like it's not something that you could do.
That's right. Yeah, it's actually something that you cannot do. So Brahma Gupta, he basically said, I don't know what the answer is, but I'm just going to say that it is a fraction with a denominator 0. Okay. But Chelsea basically said, no, that is not correct, because the closer that you get to 0, okay, so the closer that you get to 0 here in the denominator, all right, the higher you get to the solution, all right? So let me see if I think that I explained this the other way when in the previously. So let's make sure that we get x close to 0, okay? So we start with 1 divided by 1, so this point here, okay? Now we are going to get closer to 0. Let's say that we have x is 1/2, okay? X is 1/2, so X is over here. So now the function is going to go 2, okay? Then I keep decreasing this, so I'm going to go 0.333, so 1/3. So I'm going to go here. So the function is going to be here at 3. The closer that I get to X, closer to 0, the higher that this is going to go, and it's going to tend towards infinity. Okay. So if I approach 0, division by 0 from one side, I'm going to get all the way to infinity. But if I approach the division by 0 from the negative side, I'm going to get to minus infinity. So what is going to be when I get actually to 0? Is it going to be positive infinity or minus infinity? I don't know. That's why we say we cannot define it. Okay. So we say, throw up everything and say, no way, we cannot do it. So that is one of the things that I want you to remember. If you ever encounter an equation or a problem where you get, the division by 0, then it says, no, that is undefined. That is a no. Okay, we cannot do it. All right. So that is an interesting concept here. Okay. All right, and then let's see if we have. Okay, I think that is what I have here for the presentation as far as what I prepare. But so let's take a recap of what we have learned. We talk about the history of algebra. Okay, the development of algebra, the main concepts of algebra, the restoration and completion, balancing and reduction of the equations. What you do on one side of the equation, you do to the other. All right. We also talk about, the development in modern times, the contributions of Brahma Gupta with 0 and negative numbers, some of the applications of negative numbers, very practical things. And then this a very important concept that division by 0 is undefined. So we never, ever divide by 0. Okay. So if you ever find a problem, where you say, what is, I have all these numbers and then it's divided by 0, you can just say, the solution is undefined and that's it, move on. So that's all. All right. Excellent. Good. So I think that is a good start, isn't it? Okay. Any questions so far? Any questions about this? So in this course, we are going to actually be using the Khan Academy Algebra 1 course. Okay, so Khan Academy has a very good set of videos and a good sequence for an exercises and everything. So I'm going to have you join the Khan Academy class. I have a class, I'm the teacher in that class, and we are going to show you, which videos to watch and what exercises to do and everything. And so you are going to be working that way. We are also going to be using this textbook, Algebra for the Practical Man. Okay. That is a very classic textbook. It was written in the 1930s. It has some really good parts, but sometimes it goes a little bit too deep. So we are going to read basically the good parts of the textbook. Okay. So, and we will let you know what those are. And we are also going to be using GeoGebra, the algebra part of GeoGebra. Yeah, GeoGebra has a whole algebra engine. So we are going to be using that in order to do graphs and do equations and everything that way. And hopefully, I'm also going to help you learn how to use spreadsheets. The spreadsheets are very, very useful tools to help us do mathematics. Okay. So those are some of the things that are coming up in the course. All right. So excellent. Whew, we made it. Okay. Emma, go ahead.
The book is, I feel like I saw something on the questions and comments that you guys are like doing your own reprint that you want us to get.
Yes.
Is that something that's available yet? Is it in the course?
It's not yet in
Like-
the course. Okay, I'm going to put it in the course in the next couple of days and send you a notification when that is ready. All right, and then you can order it from the library that prints all of the well-educated hard books. Okay, so yeah, that is where we have it.
Okay, thank you.
The reason why we read a reprinting was because I could find a few used books of this, but there were different editions. Okay, they had maybe different page numberings and so on. I got one used book that was so musty, smelled so bad that it actually gave me allergies. I literally couldn't read it because it wasn't it was in good shape, in good condition, but it really gave me allergies. And so I didn't want you to buy something that was kind of that way. So this is a brand new reprint of the book. And it's going to be much better. All right. It's very, very economical. Okay.